Hello, I'm hoping you're having a good day. We're going to talk about combinatorics today. Now, it all started with this tweet from Fu Cesar saying, "The fact that there are only 8 ships in this frame is killing me." Now, I assume they're talking about popular ships because I don't know too much about this show, apart from watching it with my little sister about 5 or 6 years ago. But I do know, by counting, that there are more than 8 ships. So it's probably talking about popular ships. Now, then this person said they counted 32. Another person tried working with some math and reached a total of, let's see, a total of 72 human ships and 83 with Kwamis. And they also have the practical ships, which I don't know if it's number of people dependent or if it's based on the show, like on the lore, on the plot. But these are the numbers they reached. Theoretical limit. Every combination of at least 2 people or two characters. And then someone asked for a YouTube video and now I'm here. Okay, so let's start. First of all, let's look at each of the people. Each of the people have their hero personality, their human personality, and their Kwami. We're gonna first of all take the Kwamis and put them away because we are gonna solve it for humans only, and then we're gonna solve it for humans with Kwamis. But step by step. First of all, I'm gonna explain a bit about the difference between the choose function, and powers and factorial. Now, first of all, I'm going to start by saying the original calculations that Gigi did, the math there was not good. It even countered their counting. Like they had their math, which got them to 24, and then they counted and they reached 72. Now we're going to talk about that now, okay? First of all, understanding why that was incorrect. And it has to do with the use of the choose function, which, by the way, I proved the choose function in another video. I'll link it here or something. I'm not sure how YouTube creation works, so I'll try to figure it out and have it pop up or something. And if not, it's going to be in the description. But I'm not going to explain how the choose function works right now. I'm just going to link there. The problem here is the usage of it. The choose function basically allows you to take a certain number of objects and it tells you how many different ways you can choose a certain number of elements from this entire set of objects. For example, if I have these 8 pictures here and I want to know how many ways can I choose 4 pictures, how many 4 picture combinations there are here, I'm going to choose the choose function. I'm going to use the choose function, sorry, which is 8. Oops, let's zoom in a bit. It's 8 choose 4, usually denoted as 8 and 4 underneath in brackets. That's 8 choose 4, and that equals to 8 factorial over 4 factorial times 8 minus 4 factorial. In this case, it's just 4 factorial again. Factorial being the product of all natural numbers up to that number. In other words, 8 factorial is 8 times 7 times 6 times 5 times 4 times 3, 2, and 1. Okay, so that's factorial, and the choose function, that was just an example. Let's just write it formally here and to the side. If we have n choose r, why these letters? Because they usually are the ones you'll find in the calculator. So just easy to find. It's going to be n factorial over over r factorial times n minus r factorial. Okay, so that's the formula. The problem here is that if we only had these 4, we could have used the choose function. We could say how many 2 people sheep there are. It's 4 choose 2. How many 3 people sheep there are? Well, it's 4 choose 3. How many 4 people sheep there are? 4 choose 4, which is just 1, because obviously I'm going to pick all of them. So if it was just these 4, we'll have 4 choose 2 plus 4 choose 3 plus 4 choose 4. By the way, let's notice one cool thing here. If we have plus 4 choose 1 and plus 4 choose 0, then that's just every combination. So that means, okay, this thing, we're going to have every possible photo combination, including 0 photos, which means that the number of options is the same as if I went to each photo and I gave it the option to be in the set or not to be in the set. That means this photo has 2 options, either being there or not being there. So 2. This option, this photo has 2 options, being there or not being there. That's times 2. Same with this, it's times 2, and this times 2. In other words, that equals 2 to the power of 4. So that's true with every number. If you have x choose 0 plus x choose 1 plus x choose 2 plus x choose 3 and so on until x choose x, you're gonna end up like the sum of all of it is 2 to the power of x. Just putting it aside as a side note, because we're gonna later use another easier way which uses powers. So just so you'll understand the connection, how these 2 ways will reach the same place. Now, what's the problem with this? The problem with this, and you know what, let's calculate here it real quick. We know that equals to 2 to the power of 4 minus 4 choose 1 minus 4 choose 0, right? Because we say that if we add these 2 terms to here, we'll get to the power of 4. So just move them to another side. 2 to the power of 4 is 16. 4 choose 1 is how many ways we can choose one photo out of these 4. So 4 ways, either this photo, this photo, this photo, or this photo. And 4 choose 0 is just picking no photo, so that's 1 way. So that's minus 4 and minus 1. We're going to end up with 11 ships. Okay, 11 2 people ships between only heroes. Just for the practice, I'm also going to solve it as is. So 4 factorial over 2 factorial times 4 minus 2 factorial plus 0 factorial is 1, by the way, just as a side note. If anyone is curious about that, you can feel free to ask me in the comments. I will give you an explanation. And now let's solve it. 4 factorial is 4 times 3 times 2 times 1, right? 4 times 3 times 2 times 1. Notice what happens when I divide it by 2 factorial. 2 factorial is 2 times 1, so these 2 terms cancel out. In other words, I can always cancel out a smaller factorial with a bigger factorial and be left only with the access terms, and that's times 2 times 1, which is the other 2 factorial, plus 4 factorial over 3 factorial. The same way, the 3, 2, and 1 will cancel out, so I'm just left with 4 over 1 factorial is just 1, plus 4 factorial over 4 factorial is 1, obviously, So 1 over this, which is 1. This is going to be 12 over 2. So 6 plus 4 plus 1 equals 11. Okay, so that's also 11. That's not 32. So how can we get to the correct answer? And again, I can show you how I got to 32, because how they got to 32, because sadly I do not know. But let's get rid of all of this. Okay. Now what we're going to do is just space everything out a bit. Why did I do that? Let's take every combination here, okay? For two people combinations, which is this term is two people combinations. If I have two people combinations, they can either be hero to hero, right? They can be human to human. They can be human to hero, or they can be hero to human. So I have 4 ways. So that's so in order to get the true number of two people combinations, I have to multiply it by 4, because every two people combination has inside of it 4 different combinations. And by the way, if I would have just done 8 choose 2, I would also get combinations like fox hero and fox lady. I don't know. Oh, that's not fox, that's dragon. Sorry, dragon hero and dragon lady, which this obviously is not a sheep. That's the same person. Now let's think about how many 3 people combinations I have. I have the same 4 combinations that I had earlier, but now I can also choose the hero of the third, like the third person is the hero for each of these 4 combinations. And there are also another 4 combinations for the human, right? You can also think about it as I'm choosing for, let's talk about these 3 people. For each person, I'm choosing either hero or human, that's 2 options. Either hero or human, 2 options. Either hero or human, 2 options. So I'll have to multiply this by 8. And for 4 people, again, 2 options, 2 options, 2 options, 2 options. That's gonna be 16. Now, what does that equal to? Well, 4 choose 2 is 6 times 4. Okay, so 4 times 6. Is 40 plus 32, that equals to 72, which is also what this person reached by counting. 32 total. I'm trying to move the photo. 72 human ships. Now I'm pretty sure you can see it. 72 human ships, that's what they reached by counting. So these are the numbers. Now, I had another way of solving it, which was pretty, like, it was a lot easier, and I'm going to explain it now. Remember what I said earlier about being there versus not being there? That's 2 options. And then I got 2 to the power of 4 when we talked about heroes only. We can do the same when we have heroes and humans. For each ship, okay, for a ship, each person can be either the hero form, the human form, or just not there. So that's 3 options. We can do like blank boxes about them, above them, just to see. Okay, I can choose each of these 3 for each person, and then I'll get a unique ship. Of course, I have to be careful not to have empty ships or ships with only 1 person. But total number of combinations, that's 3 times 3 times 3 times 3. So that's 3 to the power of 4. And then how many 0-person ships do I have? 1. 1 empty option, right? There's in this 3 to the power of 4 different options. I have 1 option which is just choosing no one. So I'll have to subtract 1, which is also, by the way, this is No, never mind. I have to subtract 1. And then there are also how many one-person ships? There are 8 one-person ships, because it can either be this, 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 or this, right? So I have to subtract another 8. That equals to 81 minus 9 equals 72. That's a lot easier than this way, which involved a lot of counting too, okay? So that's the difference between choose and powers. Know when to use each. If you master both of them, you'll have a much easier time in combinatorics, because the thing is, with powers, you can look at the question as a whole. You can get the total number very easily. And here, the total number of ships is very close to the total number in general, you know, just of, like, the combinations. With choose, you mostly use choose when you want to pick specific options, specific numbers. Like, it's like splitting the entire array of options into tiny little sets, and then the choose function lets you pick apart those tiny little sets and know how many different combinations you have in each little set, which is 2 ships, 3 ships, 4 ships, like 2 people ships, 3 people ships, 4 people ships. But if you're gonna add them up anyway, you're better off just using the total number of options. Now, this is the first part, so 72. The second part is what got most people confused. So let's take the Kwamis as well. One moment. Okay. Now let's solve this with the Kwamis. The thing is, here, the Kwamis are not in the same group as the people. It's not just, you know, Marionette's Kwami gets added here and then I have 4 options instead of 3. No, because Marionette can be with her Kwami, with Tiki, right? It's a possible ship. It's not the same being. So we're gonna do the same thing, but then for each Kwami, we're gonna have them either be in the ship or not be in the ship. Right, so we'll add these empty options to the Kwamis. Now each of the Kwamis can be either there or not there. That's 2 options for each Kwami. And now if we wanna get a total number, what we'll do is just say 3 times 3 times 3 times 3 times 2 times 2 times 2 times 2. That's 3 to the power of 4 times 2 to the power of 4. And then we're gonna have to subtract the number of empty ships, which is one possibility with no one in the ship, like before. And then how many 1 character ships are there? 12 this time, because it can be either one, like each one of the humans, each one of the heroes, or each one of the Kwamis. And just as a side note, I know that the humans and the hero is the same person, but we counted these as 2 different ships. Adrian only and Cat Noir only are 2 different ships when we count them like this, because we have the possibility of 1, 2, 3, 4, 5, 6, 7, 8, and we also have the possibility of, instead of Adrian, it's empty, Cat Noir, empty, empty, empty. So we're gonna subtract 12 with the Kwamis, and that's gonna be 81 times 16. Oh, by the way, you know what? Even easier. 3 to the 4 times 2 to the 4 is just 6 to the 4. You can understand it easily by grouping them as 3 times 2 times 3 times 2 times 3 times 2 times 3 times 2. So that's 6 times 6 times 6 times 6 if you group them like that. 6 to the 4 minus 13. 6 to the 4 equals to 216, if I remember correctly. No, that's 6 to the 3, sorry. 6 to the 4 is 36 squared. That's so that's 1296 minus 13 equals, lastly, to the total number of ships of 1,283 total ships with, I mean, with any number of beings, right? This also includes the ship of all of them together in a huge messed up polycule, like, no, excuse me, that doesn't include all of them together, because there's like we don't have ships with the human and the hero, but this does include a lot of ships which have all 4 humans in either form and all 4 Kwamis in a very weird interspecies magical polycule. So that's the total number of ships, 1283. I hope that helped. I hope that was of good use, and I hope you could learn from it how to do combinatorics better. I hope you learn from it how you can solve these questions next time by yourself. And yeah, have a great rest of your week. Bye bye.